Probability. Okay, let's try this now. Probability. Okay, so 1, 2, 3, 5, 6. You've asked about 5 questions from this. Let's try this. The same 20 contestants on each of 3 days. So take 30 seconds, read the question statement. इसके बजाय ये एक बार पढ़ लें. How many of you have attempted these PDFs? सारे नहीं थे? Okay. ये जल्दी से पढ़ें इनके पास question statement. Done? Okay. So it says the same 20 contestants on each of 3 days answered 5 questions in order to win a prize. So we have 3 days here, and the same 20 contestants are answering 5 questions. Each contestant received 1 point for each correct answer. The number of contestants receiving a given score in each day is shown in the table above. No contestant received the same score on 2 different days. Okay. If a contestant, so now this might be important, let's just highlight this. If a contestant is selected at random, what's the probability that the selected contestant received a score of 5 on day 2 and or day 3, given that the contestant received a score of 5 on one of the 3 days? There are 20 contestants in total. That's the total number. We are given that the contestant received a score of 5 on one of the 3 days. On day 1, 2 contestants received a score of 5. On day 2, 2 contestants received a score of 5. And on day 3, 3 contestants received a score of 5. And they're saying no contestant received the same score on 2 different days. That means all of these people are different. What's the total number? 7 students. बताएं क्या कह रहे हैं आप? क्या कह रहे हैं आप? जिन्हें probability में discuss किया था, this is going to be your denominator. The total sample. So remember the probability formula: number of favorable outcomes divided by the total number of possible outcomes. This, given that thing, restricts the total number of possible outcomes. It affects the denominator of the probability. So they're saying it's given that the contestant received a score of 5. What's the total number of possible contestants who satisfy that criteria? 7. 2, 2, 3, that's 7. So 7 is your denominator. Okay? Now, out of these 7 people, they are saying if a contestant is selected at random, what's the probability that this received a score of 5 on day 2 or day 3? Out of these 7, how many received a score of 5 on day 2 or day 3? 2 plus 3, that's 5. That's your numerator. So you say it's 5 over 7. That's the probability. Out of those 7 people, 5 received a score of 5 on day 2 or day 3. Okay? So whatever is given, that is your denominator. Okay? All right, that was question number 2. Question 1, sorry. Now 2. Human blood can be classified into 4 common blood types: A, B, AB, and O. It's also categorized by the presence or absence of the rhesus factor. I'm not sure what that is. The table above shows the distribution of blood type and that factor for group. Okay, so we have A positive, B positive, AB positive, O positive, and similarly for we have negative. If one of these people who has a blood type that is negative is chosen at random, One of these people is chosen at random, right? That's what they're saying. The probability that the person has blood type B is 1 over 9. What's the value of X? We are selecting one person from these people. What's the total number of people here? 7 plus 2 plus 1 plus X. Out of these, the probability that their blood type is B, that's 2. So that's 2 over this. This should equal 1 over 9. And that should give you the value for X. Okay? Cross multiply kar that gives you 18 equals 7 plus 2 plus 1, that's 10. So 10 plus X equals 8. You write 8 here. Okay? All right. Next is question number 3 from this. An alumni association survey asked each high school graduate to select one activity he or she preferred for the association's next event. Okay, so these are the possible activities. And you have phone and email. Okay. Some of the people responded by phone and others responded by email. The table shows the distribution. Okay, now this is the important part. For the survey, the number of email responses was twice the number of phone responses. The number of email responses was twice the number of phone responses. If a person who preferred a picnic is selected at random, so who are we selecting? A person who preferred picnic. What's the probability that the person responded by email? Okay, now how do we think about this? They're saying the number of email responses was twice the number of phone responses. What we can do is we can write some numbers here. So we can say, let's suppose the number of phone responses was 100. Okay. Let's get rid of the percentages. Let's say out of 100, 55 preferred dinner dance. I'm not sure why that would be, but that's what they're saying. Out of 100, they're selecting 55. Okay. And then football game is 20 and so on. The number of email responses was twice the number of phone responses. So if that is 100, what about this? 200. And now you change these numbers accordingly. This is 160. What are we concerned about? The number of preferred picnics. So let's just focus on that. So instead of 5, let's say this is 10. These are the actual numbers now, rather than percentages. Okay. So the rest of them will be, this will be 10, this will be 20, this will be 160, right? Out of 200. What's the probability that the person responded by email if a person who selected picnic was selected, who preferred picnic was selected? What's the total number of people who preferred picnic? 30. Out of 30, what's the probability that they responded by email? 10 out of 30. So that's 1 over 3. Is that okay? That was question number 3 from this. Any problems? No? Okay. Next is question 5. All right. So again, we have a table. Sorry. Okay. The table summarizes the distribution of age in a assigned group for 90 participants. So we have 90 participants in a study. That's the total number. You have this distribution. One of these participants will be selected at random. What's the probability of selecting a participant from group A given that, again, given that the participant is at least 10 years of age? So who are we selecting from? We're selecting out of these people. At least 10 years means they could be 10 to 19 or 20 plus years old. So out of these 60 people, we are selecting someone. So the total number is 60. Okay. Out of these 60 people, what's the probability that the participant is from group A? 14 plus 9. And that would be 23 over 60. What's given? It's given that the participant is at least 10 years of age. जो given होता है, that is the total number of possible outcomes, because we know for sure the person that we are selecting, they have to be at least 10 years of age. That means this is not relevant. We're only selecting out of the remaining people. What's the total number of remaining people? That's 60. So that's your denominator, total number of possible outcomes. Out of those, 23 are from group A, so probability is 23 over 60. Okay? So whatever is given, that becomes your denominator. Okay, next is 6, the last one from this PDF. To the nearest tenth of a percent, okay, so the table shows the distribution of US states according to which they have state level sales tax and state level income tax. Okay, so whether they have a state level sales tax and a state level income tax. Okay, so it's like these 39 people have both sales tax and income tax. These 4 people have income tax but no sales tax, and so on, right? So you have 4 possible possibilities here. Now it says to the nearest tenth of a percent, what percent of states with a state level sales tax? Now again, read the question statement carefully. What percent of states with a state level sales tax? What's the group that we're talking about? Who have a state level sales tax? What are those people? What are those states? These 45 states. We are only talking about these 45 states. Is that okay? What percent of this number do not have a state level income tax? Out of these 45, who do not have an income tax? 6. So that's 6 over 45 in percentage. It will be 6 over 45 into 100%. You can see what that is. 13.333. Now they say to the nearest tenth, that would become, okay, now this is important. 13.3%. Tenth means 0.1%, right? So that's 13.3%. That's your final answer. Is that okay? No problem? ठीक है? नहीं? So this was question number 6. Let's move on to the next one now. Okay, now we have percentages. Percentages. Sorry? 525 no break. 520 no break. 520 no break. Okay? Alright, percentages. Percentages come way. Yeah. Okay, so there are a number of questions from this PDF now. Okay, first of all, we have question number 1. Let's try this. Jennifer bought a box of crunchy grain cereal. The nutrition facts on the box state that a serving size of 3 over 4 cup. Okay, let's actually look at the last statement first. What are we looking for at the end? Which of the following expresses P in terms of X? Okay, and what's P and X? P% of an adult's daily allowance is provided by X servings of the cereal per day. Okay. P% of an adult's daily allowance is provided by X servings of crunchy grain cereals per day. Which of the following expresses P in terms of X? Okay, now what are they saying? The serving size of the cereal is 3/4 cup and provides 210 calories, 50 of which are calories from fat. Now that looks like a lot of irrelevant information. The upper numbers like 3 over 4 cup, 210 calories, 50 of which are from fat. We're not really interested in all of that. That's just additional information to confuse you. Yes. That's basically to confuse you because it does not really make any sense. Each serving of the cereal provides 180 milligrams of potassium, which is 5% of the daily allowance for adults. Now, this is the important part, right? That one serving of the cereal is 5% of the daily allowance. Okay? One serving is 5%. What about X servings? What would that be? 5x percent, right? It says P percent. So if we compare it with P percent, what's the value of P? P is 5x. That should be B. Okay? So this actually tells you why it is so important to look at the question at the end first, so you know what to look for in the question. Otherwise, you'll get confused about what they're really saying here. 210 calories, three-fourth cup, out of which 50 are from fat. That's a lot of irrelevant information, which is not really required. Is that okay? All right. Next from this PDF is question number 3. The manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. How many subscriptions did the manager expect would be sold in 2014? Okay, so what is the expected number here given that the percentage increase from 2012 to 2013 would be double the percentage increase from 2013 to 14. Okay, let's first find this percentage increase. How do you find this percentage increase? New value minus the old value divided by the old value. What's this percentage increase? 280. 280 divided by 5600 multiplied by 100%, that is 5%. Okay, so this number is 5%, this increase is 5%. Now they're saying this percentage increase is double the percentage increase from 13 to 14. So this should be 2.5% increase. Question statement दोबारा से पढ़े. The increase from 2012 to 13 is double the increase from 2013 to 14. So 2013 to 14 should be half of that. So this is 2.5%. Now you just want to increase 5880 by 2.5%. You can do that directly like this. 5880 multiplied by 100% plus 2.5%. That's 1 or 2.5%. In decimals, that would be 1.025. You just multiply by this with this directly and you get the result. You can see what that is. 5880 into 1.025. 6027, that should be B. Is that okay? Okay, let's move on. That was question number 3. Question 4. The line graph shows the total amount of snow in inches recorded each year in Washington from 2003 to 2015. Okay, you can see that in the graph. If P percent is the percent decrease in the annual snowfall from 2003 to 2007, what's the value of P? What's the percentage decrease from 2003 to 2007? In 2003, the number is 40. In 2007, the number is 10. What's the percentage decrease? 10 minus 40 over 40 into 100%, that will be minus 75%. Now they're saying P percent is the percentage decrease. Decrease already incorporates the negative sign. So you'll say this is 75%. What's the value of P? It's 75. It's a 75% decrease. Make sense? Okay? That was pretty straightforward. That was question number 4. Next is 5. The number A is 70% less than the positive number B. The number C is 80% greater than A. The number C is how many times B? Let's write each of these statements in an equation form. A is 70% less than B. How do you write that? A equals 70% less. What's that? It's not 0.7 times B, it's going to be 0.3 times B. 70% less, 100% minus 70%, that's 30%. So that's 0.3B. Okay? The number C is 80% greater than A. C is equal to 1.8 times A. C is how many times B? So eliminate A from this. Just input this there. C is equal to 1.8 into 0.3 times B. What do you get from that? 1.8 into 0.3? 0.54B. Now they're saying how many times is C as compared to B? So you'll say 0.54. It's 0.454 times. Okay? No problems? Okay, let's move on. That was question number 5. The next is 7 from this PDF. Okay, take 30 seconds to read the question. Okay, according to the 2010 census, the adult population aged 18 years or greater was this. Okay, this might be an important number. 18 years or greater. In 2010, a survey was conducted among a random chosen sample of these people about their preference to live in a warm climate or cold climate. Okay, so you have this information given in the table below. Which of the following is closest to the difference between the percentage of adults aged 18 to 15 years who responded warm and the percentage of adults aged 51 years or greater who responded warm? 18 to 50. That's these two rows. What's the percentage of these people? What's the total of these people? This is the total of these people, right? Out of these, how many responded warm? This number. So what's this percentage? You can calculate this. This is how you would do it. 295 plus 246 divided by 508 plus 410. This percentage is 58.9%. Okay? Now it says percentage of adults aged 51 years or greater who responded warm. So out of the remaining people now, these are the remaining people. How many of these responded warm? Again, do the same thing here. 238 plus 137 divided by 403 plus 279. We get 55.0 from this. What's the difference between these two numbers? 3.9%. So it's 4%. That's what is closest to this. Difference find करना था दोनों में. Is this clear? Make sense? Okay, that was question number 7. Next is 13. 37% of the items in a box are green. Of those, 37% are also rectangular. Of the green rectangular items, 42% are also metal. Which of the following is close to the percentage of items in the box that are not rectangular green metal items? Okay. Let's say the total number of items is X. Let's say the total number is X. 37% are green. What would that be? X multiplied by 0.37, right? Of these, 37% are also rectangular. So calculate 30%, 37% of this as well. 0.37 again, right? Whatever is this total number, you again multiply that by 0.37. Of the rectangular green items, 42% are also metal. So out of this number, 42% is metal. So you also multiply this by 0.42. Which of the following is close to the percentage of items that are not rectangular green metal items? What's this number? Let's calculate this first. 0.37 into 0.37 into 0.42. That's 0.0575. In percentage, that would be 5.75%. Is that okay? These are green rectangular metals. Now, how many are not green rectangular metals? 100 minus this number. And that will give you C, 94.25%. That's the number that's not green rectangular metal. Is that okay? So we just calculated for the original number 37%, again 37%, again 42%, and that gives us the total, right? And subtract that from 100 then. Okay, the next one and the last one from percentages is 15. The value of a collectible comic book increased by 167% from 2011 to 2012. By 167%. What does that mean? Increase by 167%. If initially it was 100%, it becomes 267%. Right? That's an increase by 167. If it's at 167, that would just be 167%. Okay? So from 11 to 12, that's the increase. Then it decreased by 16% from 2012 to 2013. What was the net percentage increase in the value from 11 to 12? Okay, so how do you figure this out? Let's say the initial was X, or you can give it a number. You can call it 100 as well. That's another way to think about this. If you're calculating percentages, you can start from 100. Okay. Instead of X, you could also say 100, right? Let's start from 100. 167% increase. What does that mean? You multiply this by 2.67. Is that okay? That would be a 167% increase. And then you decrease it by 16%. You multiply it by 0.84. Right? 1 minus 0.16, that's 0.84. Let's see what that gives us. 2.67 multiplied by 0.84. 100 into 2.2428, and that is 224.28. What's the percentage increase? What's the percentage increase? Hundred to 224. That's a 124.28% increase, right? Is that okay? इसको आप इसमें से आप 1 माइनस कर दें 2.2428 minus 1 that gives you 1.2428 in percentage that's 124.28%. Yes. कर सकते हैं. Yes, so you can say 100 plus 167, but then you have to calculate 16% of this complete number. 100 का तो 16% ना, उस पूरे का करना है, तो फिर वो करना पड़ेगा 267 in 2.84, वो सब ट्रैक करेंगे उसमें से. You can do it that way. But this is much quicker. I would really encourage you to get very comfortable using factors like these. Percentage increase करना है या decrease करना है तो किस number से multiply करना है उसके लिए. We did this in detail when we did percentages. Okay, so that was the last one from this PDF. Let's move on. Next one is ratios, rates, proportions, and units. Okay, just give me a second. I need to attend to call. Okay, let's begin with this. So the next one is ratios, rates, proportions, and units. So from this PDF, you've asked about questions 3 and 4. Okay, let's look at these two questions. Question number 3. Okay, so that's a lot of information given. What are we looking for? How many megawatt hours of energy would the 9 projects have produced? Okay, uh, we have these 9 projects. We have some locations given and power capacities given. The total power capacity for projects located for 9 wind projects. Okay, for 9 wind projects located in Texas was 4952 megawatts. Okay, we're talking about Texas here. And the total power capacity for of the 20 wind projects was 11,037. Okay, so this whole data is for 20 largest wind projects. Out of those 20, 9 are in Texas. Okay. The amount of energy produced in 1 hour at a rate of 1 megawatt is 1 megawatt hour. In each of the 9 Texas wind projects in 2013, they operated for 24 hours at the maximum rate of power generation. The data is about 2013. Approximately how many megawatt hours of energy would the 9 projects have produced? So we're only focusing on Texas. These are 9 projects in total. Some of them have a low power capacity, some of them have a medium power capacity, some of them have high power capacity. What does low, high, and medium mean here? Why? Low. Does it define low, medium, and high anywhere? Okay, so we don't really care about that, to be honest. Yeah. So we know that the total power capacity is 4952. The table is kind of irrelevant in that sense, right? The total power capacity is 4952 for the 9 projects in Texas. That's the total power capacity. If they're running for 24 hours, how many megawatt hours of energy would they produce? 1 megawatt hour is the energy produced in 1 hour. So you just multiply this by 24. That's one thing. Are we talking about one day? Yeah, so just for 24 hours, just multiply this for 24. Let's see what we get from that. 4952. What do we get? 11884. 8848. Okay, so that's 118,000. If you round that off, that should be D, 120,000. So that table is like irrelevant. They just gave that to confuse you because they've not even defined what low, medium, and high mean. They've given this information in the question itself. This is the total power capacity, and that's running for 24 hours. Just multiply those two numbers and you get the result. Okay, so that's a lot of extra information. ये clear है, Zaira? ओके क्लास में वैसे भी नहीं है वो मतलब मेंटली तो आप लोग नहीं है यहाँ पे ओके क्वेश्चन नंबर 4 was the next one. Yeah, question 4. If 4a over b is equal to 6.7 and a over bn is equal to 26.8, what's the value of n? Okay, now how do we think about this? There are two equations, three unknowns, so you can't really find the values of all the unknowns directly. However, you have a over b here. You can say a over b is equal to 6.7 over 4, which is 67 over 40. Okay, just leave it like this. 6.7 over 4. Let's just leave it like this. Now, in the other equation, you have a over bn equal to 26.8. In place of a over b, you can write that. You can say that 6.7 over 4n equals 26.8, and that's going to give you the value for n, 6.7 over 4 into 26.8. You can see what that is. 6.7 divided by 4 into 26.8, and that's giving me 1 over 16. N is 1 over 16.